Welcome to qnawire.
Question 89 starts by asking, what is electrolysis for part A? So electrolysis is it's an electrochemical process. Electrochemical process. Um, but unlike a voltaic cell, which is spontaneous, this one is non-spontaneous. Therefore, in order for this to occur, energy is going to need to be supplied. Um, and you're generally going to supply that with some outside power source, using some outside power source like a DC battery or something like that. So you're going to need to supply an outside power source. So you are forcing a redox reaction in the direction that is non-spontaneous, basically. Question B says, are electrolysis reactions thermodynamically spontaneous? Well, I just sort of answered that, and the answer is no, they are not thermodynamically spontaneous, kind of based on the above definition of what what electrolysis is. It's by definition non-spontaneous. That's why you have to supply a power source. Question C says, what process occurs at the anode and in the electrolysis of molten sodium chloride? So I have liquid sodium chloride, molten sodium chloride, and I want to know what process occurs at the anode. So remember that oxidation is what's going to occur at the anode. So I'm looking for the oxidation reaction. And sodium, so here, let's break this down. This is sodium with a +1 charge, chloride with a -1 charge. There is no more positive version of sodium ion, so it can't be that's being oxidized. Therefore, it's going to have to be the chloride that's being oxidized. So when chloride is oxidized, it becomes, the reaction is going to end up being 2Cl minus goes to Cl2 plus 2 electrons. So that's going to be the oxidation reaction that will occur at the anode. And finally, why is sodium metal not obtained when aqueous solution of sodium chloride undergoes electrolysis? And that is because, so there's two possibilities for the reduction reaction. The first is the sodium going to sodium metal by adding 1 electron, and the other is the reduction of water, and taking water to hydrogen gas. And since we're adding energy, it's going to go the path of least resistance, basically the one that requires the least amount of energy, so that the overall cell EMF is the lowest, and this is going to supply that lowest amount of energy is going to be required for this, because it has an E of 0. And so the difference here is going to be smaller than the difference would be between these guys. Again, when you're supplying energy, it's going to go with the path of least resistance, the lowest energy possible, and this reaction is lower than forming sodium metal.